Hi, everyone. In yesterday's assignment, you guys did a really great job of being self-reflective and really attempting these problems and trying to think about where you were getting stuck and what you needed to do next. I looked through your responses on the Schoology quiz, and it seemed like some people might benefit from just seeing the solutions worked out to numbers 14 and 17 from the Schoology quiz, the ones that were in your homework packet yesterday. So that's what this video is for. So if you know how to do these problems, you were able to figure out your mistakes, you don't need to watch this video. But if you still just want to see the solution worked out, this video is for you. So in your homework packet on page 6, find question 14. And I'd like you to just look at what you wrote yesterday and compare it to what I'm working through and see if you can figure out where you made a mistake, if you were having a hard time with this problem. The problem says how many grams of oxygen are needed to react with 12 grams of methane. So just to save time in the video, I already calculated the molar masses of them here. We're solving for grams of oxygen. And I'm just going to circle where that is in the equation too, so that you can see where the mole ratios come from. We are starting with 12 grams of methane. Methane is here in the chemical equation. And remember, if there's no coefficient, that coefficient is a 1. So I am going to start with my given over here on the left, 12 grams methane. One of the most common ways that people make mistakes when they solve stoichiometry problems is by not writing the units and the chemical substances. So when you write your work, so that you can keep track of your units, you have to write it like this. Otherwise, you're very likely to make mistakes and write the wrong thing in the numerator or the denominator. So I'm going to start by 12 grams of CH4. My first conversion factor is going to be using that molar mass of methane because I want to convert grams into moles. The whole idea behind the mole ratio is we can only do stoichiometry if we can compare moles of the two substances. So any masses we're given in an equation, they have to be converted to moles. So I need grams of methane on the bottom in order for that to cancel. And I need moles of methane on the top. This is where my molar mass over here comes into play because there are 16.0326 grams of methane for every 1 mole of methane. Now I need my mole ratio. That's going to come from these coefficients up here. I got a 1-to-2 ratio. So 1 mole of methane needs to react with 2 moles of oxygen. And we're solving for oxygen, so that's good. If you're kind of working along, you can cancel units as you go too. Grams of methane cancels. The reason these things cancel is because anytime you have something in the numerator and denominator of a fraction, it will cancel out. So I cancel those. And now I'm at my final step where I need moles of oxygen on the bottom and grams of oxygen on the top, because that's what I'm solving for, grams of oxygen. So I'm going to use my molar mass of oxygen now. There are 32.998 grams for every 1 mole of oxygen. So the most common wrong answer that I saw when I looked through the Schoology quiz was 24 as a final answer or something along those lines. I'm guessing that you probably left out the mole ratio or something. But when you do the final math for this, remember you need to multiply everything on the top and divide by everything on the bottom. So what you're going to type in your calculator is 12 times 2 times 32.998. All of that divided by 16.0326 times 1 times 1. So when I type all of that into my calculator, what I got was 47.9 grams of oxygen, so about 48 grams of oxygen. All right, so that's the final answer for that problem. All right, let's move on to number 17. Number 17 is also a mass-to-mass equation, and I, again, wrote out the molar masses just to save time here, but it says if we have 75 grams of lithium nitride, that's Li3N in the equation. How many grams of lithium hydroxide can be produced? Okay, so let's just like we did before. Let's start over here on the left. 75 grams of lithium nitride. I'm going to use that molar mass. So there's 34.83 grams of lithium nitride for every 1 mole of lithium nitride. So that'll tell me essentially how many moles of lithium nitride am I starting with. Now I need that mole ratio. I'm going to find my mole ratio in the chemical formula, or in the chemical equation. So it looks like we have basically 1 lithium nitride producing 3 moles of lithium hydroxide. Those are the coefficients. Remember, if there's no coefficient, the coefficient is 1. So my mole ratio here is a 1-to-3 ratio. 1 mole lithium nitride to 3 moles lithium hydroxide. So hopefully you see where I found that from the coefficients in the chemical equation. And now I need to convert those moles of lithium hydroxide to grams. So this is where I use the molar mass. Moles lithium hydroxide to grams. Notice how sometimes I just write out the units before I write the numbers. I find that helps me to keep everything straight as I go. So 23.9479 grams of lithium hydroxide for every 1 mole. Those units cancel, moles of lithium hydroxide. So now I want to multiply everything across the top. 75 times 3 times this, divided by 34.83 times 1 times 1. And then when you type all of that into your calculator, you should get something like 154.7. And the units on that are grams lithium hydroxide. So about 155. Okay, so I hope you see how important it is that if you write the units with the chemical formula the whole way, it's so much more straightforward to figure out if the units are canceling. That's such a common mistake I see from students. So it's likely that if you had a hard time with these, that's the mistake you are making. Okay, let's move on to the last question here, which says, if only 132 grams of lithium hydroxide are recovered, what is the percent yield? So if I got 154, basically what percent yield means is if I had gotten exactly 154 grams, that would be 100% yield. But this is not 100%. So to solve this problem, we just take 132 divided by 154.7 times 100. It's just your typical percent calculation. So 132, I didn't do this one yet on paper. Okay, so that's about 85%. All right, so that's how you would do that. I hope that this helps clarify some things for you. If you're still feeling like you want more practice on these gram to gram conversions, I would say you should do on page 7, the more practice problems, number 6, 7, and 8. Those are pretty much exactly like these problems, so they would be great additional practice. And if you still are having a hard time or like you have questions that you just feel like you can't get answered from watching these screencasts, please find a time to talk to me during my office hours, because one of the big challenges of e-learning is you can't ask me questions in person, as we're working through these things. So, you have to learn how to be a good advocate for your own learning. And I would really love to meet with you during my office hours to help make sure that you're feeling comfortable with all these skills.